All right, this is lesson 1.3 in Geometry A. We're talking about is midpoints and distance formulas. Okay, there's a couple different formulas that we have to get used to in this lesson. A couple different formulas that we'll be using throughout the entire trimester, not just in this lesson. All right, this first exploration says graph AB, where points A and B are as shown. So we have to graph this segment AB. Remember, a line segment has two endpoints and a line in between. So we have point A, point B. Our line segment is going to go right in between there. Now imagine that's a straight line. Okay, I don't have a straight edge for my smart board. I wish I did, but I don't. Part B says explain how to bisect segment AB. Okay, it says that is to divide segment AB into two congruent line segments. Definition for you. Bisect. Bisect is to split into two equal parts. So whenever you see or hear the word bisect, it is directly in the middle, right? Bisect. Split into two equal parts. Okay? So we have to bisect segment AB to find the results of midpoint M. Okay, so we're trying to find the midpoint of this segment. How do we do that? Well, right now, how do we find that? What I discovered is that when graphing this line, I noticed that it had a slope of up 1, 2, 3, 4, 5, 6, up 6 over 1, 2, 3, 4, 5, 6, 7, 8 over 8. Right? So it had a slope of 6 over 8, which can simplify to 3 over 4. Okay, well if I go up 1, 2, 3 over 1, 2, 3, 4, notice there's a point right there. If I go up 1, 2, 3 over 1, 2, 3, 4, there's my other point. Okay? So my midpoint was halfway, right? Halfway of AB, which is right there. It's at -1, 1. Okay, so there's our midpoint, -1, 1. We got that for part C. Now I can erase this and scroll down. So if M was at -1, 1, the coordinates of A, what were the coordinates of A? 3, 4, and -5, -2. 3, 4, and -3, 4. So A was at 3, 4, and B was at -5, -2. Yes. Okay, now compare the x coordinates of A, B, and M. Compare the y coordinates. Okay, let's start with the x coordinates. Well, if A is at 3, A is at 3, right? 3. B is at -5. So 3. Let's start with the number line. Let's do a number line. Okay. Here's 0. We have 1, 2, 3. There's A, and we're at -5 for B. And M is at -1. Sorry, let's draw M and let's draw B. Okay. The midpoint should be directly between A and B, right? Let me ask you this. Actually, let me tell you this. The middle point is the average of the two, correct? The middle point of any 2 points should be the average. So let's say you get 90% on your test. right? Let's say you get 90%. And your friend gets 70% on their test. So you get 90, your friend gets 70. What's the midpoint between you two? What's the midpoint? Well, the midpoint would be between 90 and 70, which is 80. Okay? But how else can we find that? How else can you find average? Well, you can take the two amounts, 90 and 70, add them together, we get 160, and we divide by the amount, which is 2, right? 160 divided by 2 is 80. So again, we can do this. We can say, well, 3 plus negative 5 is equal to negative 2, right? And negative 2 divided by our amount, right? 1, 2. So divided by 2 is equal to negative 1. Look at that. We found our x-coordinate, negative 1. Let's try that same thing, but with the y's. Try that same thing, but with the y's. We have 4 and negative 2. I'm going to go up top here. We have 4 plus negative 2, which is 2. We're going to divide 2 by 2, which is equal to 1. Perfect. So we found our y-coordinate too. Okay. We'll get into the formula here in a second. We'll get into the formula in a second. But that's one way to find the midpoint. Exploration 2. Add point C to your graph as shown. Okay, so we have our graph here on the right. Use the Pythagorean theorem to find the length of AB. Remember, the Pythagorean theorem from Algebra 1 or 1.5, we had A squared plus B squared is equal to C squared, where C squared is the hypotenuse of a right triangle, right? C squared is going to be this diagonal line, C squared. And if we draw our triangle, our right triangle, remember we can only use the Pythagorean theorem on right triangles. Okay, here's our right triangle. Doesn't matter. Either the base or the height is A squared or B squared. It does not matter. We'll say that this is A squared and this is B squared, but it can be vice versa. Doesn't matter. We have to find the distance for A squared. How do we do that? Well, A squared is 1, 2, 3, 4, 5, 6. So we know that 6 squared, I'm sorry, these shouldn't be squares. These should just be A's, B's, and C's. Okay? So, sorry, A is 6, and we square 6, plus B is 1, 2, 3, 4, 5, 6, 7, 8, plus 8 squared is equal to C squared. Do a little math, we get 36 plus 64, which is 100. So 100 is equal to C squared, the square root of C squared, and the square root of 100, 10 is equal to C. So our distance from A to B is 10. Okay? So that's our Pythagorean theorem. Good. Good. Our distance from A to B is 10. What does part D say? It says use the Pythagorean theorem and point M in exploration to find the lengths of AM and MB. Well, come on. We know what, if it's a midpoint, right, of AB, right, AB was equal to 10. Well, if M is truly the midpoint, that should be halfway between 10 and 0, right, which is 5. And MB should equal 5 as well. We really don't have to use the Pythagorean theorem there. Okay. How can you find the midpoint and length of a line segment in a coordinate plane? Well, we can find the midpoint by using this formula. Here's your formula for midpoint. Midpoint is x1 plus x2 divided by 2, comma, this is a coordinate, right? So that just found our x coordinate. Then our y's, y1 plus y2 divided by 2, and there's our y coordinates. Okay, and the length, we can use the Pythagorean theorem. Find the coordinates of the midpoint M and the length of the line segment whose endpoints are given. Okay. I'm going to let you work on those, A and B. You guys can pause the video and work on those quick. I am going to move on. In your own words, write the meaning of each vocabulary term. Midpoint is the middle point. Between 2 points. 2 points, yeah, there you go. A segment bisector is a line, oh, sorry. Let me make sure I get this definition correct. I don't want to lead you guys astray. So, a segment bisector is a point, ray, line. So it's kind of close. I want to make sure I get all of these. A point, ray, line, line segment, or plane that intersects the segment at the segment's midpoint. Okay, so it's really anything that intersects a line segment at the line segment's midpoint. Okay, it can be a point, it can be a ray, it can be a line segment, a line, a plane, it doesn't matter. Anything that goes through the line segment right at the midpoint is its segment bisector. Moving on. The midpoint of a line segment is the point that divides the segment into 2 congruent segments, right? So this midpoint M here is the midpoint of AB. Okay, so AM is congruent to MB. We know that, right? It's a midpoint. That makes sense. So this point here, or this line segment here, is congruent to this line segment here. Okay. A segment bisector is a point, ray, line. Yeah, we just got that. Some notes here. There's the midpoint formula for you. It's really just the average of the x coordinates and the average of the y coordinates. The distance formula. The distance formula. This is important to know. I like the distance formula. I like to use it more than the Pythagorean theorem because it will always give me a right answer. I do not need a right triangle. Okay? I can just plug in my points and get my distance. So I actually like to do this with my points A and B. So I'm going to scroll up here. 3, 4, and negative 5, negative 2. 3, 4, negative 5, negative 2. So A was at 3, 4. That's what A was at. And B was at negative 5, negative 2. Okay? Using this formula, it does not matter which coordinates are your x1, y1, or your x2, y2. It does not matter. Okay? So let's say this is x2, y2, and let's say this is x1, y1. Okay? When we plug this into our distance formula, we have x2 minus x1. So 3 minus a negative 5. So 3 minus a negative 5. That's going to be squared. We're going to add that to 4 minus negative 2. That's also going to be squared. Okay? Keep our square root. We have 3 minus a negative 5. What's 3 minus negative 5? Well, that's 8, right? Positive 8, because minus a negative, we can turn this into one big positive, and 3 plus 5 is 8. So 8 squared plus 4 minus negative 2. Again, we can turn this into a plus. That's 6. 6 squared. That's equal to the square root of 64 plus 36, which is equal to the square root of 100, which is equal to 10, which is what we got. Okay? So you can turn triangle or segments into right triangles, or you can just use this distance formula. So extra practice here. I'm going to go through a few of these, and then I'm going to let you do the rest. Exercise 1 through 3. Identify the segment bisector of AB. So we have to identify what is bisecting segment AB. Then we have to find AB. Well, so number 1, what is right in the middle? It's point M. Right? So we can say point M is its segment bisector, and AB, well, if AM is 13, then we have to know this is 13. And 13 plus 13 is 26. Sorry. AB is 26. Yeah? Number 2. What is bisecting AB? Well, it's not just point M, it's actually this ray. It's a ray because it has an endpoint and an arrow going in one direction. So ray MC. We can also just say MC with that little mark right there. And if AM is 8, well then MB is 8, and 8 plus 8 is 16. So AB is equal to 16. Lastly, it's not just this point, it's this whole line going through AB. And what's that line? How do we say that? That's line L. Okay. And if MB is 26, well then AM has to be 26. So AB is 26 plus 26, which is 52. And this is what your homework will be like. Naming the segment bisector and then finding the distance. I want you guys, well, I'll do one of these. Okay, I'll do one. I'll choose number 5. I want you guys to try 4 and 6. First, we have to identify the segment bisector. Well, first of all, it's not just a point, it's this whole line. Line M is the segment bisector. Then we have to find EF. We have to find this whole distance. Okay? Well, it's given us variables. That throws me off a little bit. Throws me off just a tad. We have to add both sides. X plus 15 plus 7x minus 3. and that's what's going to equal EF. If we combine like terms, we get 8x plus 12. Okay. Can we solve this? Can we solve this? Can we go any further? No, we can't. This is our distance. So 8x plus 12 is equal to EF. And we can't solve that any further. The endpoints PQ are given. Find the coordinates of the midpoint M. Okay, well, here we go. I'll go through one of these, and again, you guys can do the rest. I'll go through number 8. Remember, we have to find the average. Let's start with our x's. If we add these together, -2 plus 10, and divide by 2. And then our y's, 7 and -3. So 7 plus a -3 over 2. Our x's, -2 plus 10 is positive 8 over 2, which is 4. And there's going to be a comma, because it's a coordinate. 7 plus -3 is 4 divided by 2, which is 2. There's our coordinates of our midpoint. Okay. These ones down here, little trickier, but it's not too bad. Let's pay attention here. Last little bit of this video, and then we'll be wrapped up here. In exercises 10 through 12, the midpoint M and one endpoint, okay, of JK are given. Okay, so if we have our line segment here, we have J at 7, 2. We have M at 1, -2. We have to find K. We don't know where that's at. We do not use the midpoint formula here. Instead, it's as easy as this. Count the spaces between the x's, okay? So if we go from 7 to 1, how far back did we go? We went down 6, right? We went -6, because 7 minus 6 is 1. If we went from 2 to -2, how far back did we go? We went -4, okay? Well, that's what we have to do again. We have to repeat that to get to K. So 1 minus 6 gets us -5. So we know that our x-coordinate is -5. And if we go from -2 and we do -4 again, -2 minus 4 is -6. There's our coordinates. Okay. All right, so try those last two. Those can get a little tricky. All it takes is a little bit more practice.